Okay, let's get started. So last time we were basically, started understanding overall how machine learning works, was the importance of decision tree, and how these things comes together in terms of, deep learning, NLP, and the other, paradigms which we talk about quite frequently, right? So let's revise these things so that we'll understand where we have reached in terms of our progression and how we basically start implementing the solutions. So machine learning is a study of computer algorithms that can improve automatically through experience and by the use of data. I just want to mention here, yesterday I shared two books with you. These two books are really important where we can understand how this machine learning is implemented via various different libraries available as of today. And those are with the latest versions. One with basically the introduction of machine learning and the progression. The second is basically building data scientist solutions. Okay, so those books are really important. If you can open your WhatsApp, where was that? No, okay, yes, let me open that thing. Yes, the first book is basically hands-on machine learning with scikit and keras and TensorFlow, concept, tools, and techniques. This talks about a really good solution building in terms of machine learning. Then the second one is basically introduction to machine learning. Here, it basically talks about how Python supports the machine learning. Okay, oh, sorry. I'll start that share here, right? So you can see, what are these two posts I'm talking about. Okay, these are IST timing, so don't worry about these things. But you'll find these links. Please do download these things. These two books, they are really good reference material for our next journey. Okay, let me go back to our presentation and let's start understanding how we can utilize these books to make sure we are in line with the thought process. It is seen as a part of AI. Machine learning algorithms build a model based on sample data, known as training data. We'll understand this statement in depth today. I have added a couple of slides here to make sure you could answer all the questions, whatever there in interview on machine learning specifically, in order to make the predictions or decisions without being explicitly programmed to do so. Now we'll understand this statement as well. We discussed it last time. What we are trying to do here, we are trying to guide the machines to learn by themselves. How do we do it? We'll see that. How does the thought process initiated? How does this overall, learning scientific approach have initiated? We'll see that today. Machine learning algorithms are used to a wide variety of applications, such as medicine, email filtering, speech recognition, blah 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 blah. There are lots and lots of applications as of today. The face recognition and everything comes under machine learning. So what we are trying to do, we are trying to let the machine guide us on a step-by-step way in terms of they are learning from their events, they are learning from their progressive decision tree branches. A subset of machine learning is closely related to computational statistics, which focus on making prediction using computer. So based on my historical artifact or historical data I have collected, how was the consumer behavior in the last month? How was the seasons, temperatures, rain predictions in the last month and the months in the previous year? And from that, I extrapolate the data to understand how today or the current months looks like, current weeks looks like to me, and so on. So this is what we are just extending the curves, or this is what we call extrapolation in a data scientific terminology. But not all machine learning is just statistical learning. The study of mathematical optimization delivers methods, theory, and application domains to a field of machine learning. Data mining is also a related field of study, focusing on exploratory data analysis through unsupervised learning and some implementation of a machine learning use data and neural networks in a way that mimics the working of a biological brain. And this is what we call neural linguistic programming, not the psychological one, but we have a psychological one, but we have a specific branch to try to replicate the brain's working in the machine learning. And we'll see that as well. in its application across business problem, machine learning is also referred as a predictive analytics. So we study
Yeah, is everyone able to hear Ravindra?
I think we lost his audio. Yeah.
Oh, okay.
Yeah.
I thought it was just me actually. Yeah.
No, me too. I lost.
Yeah, I got caught off guard for a second.
Looks like there's a power failure there. And,
Okay. Yes, pardon me. Could you hear me?
Yeah.
Yeah, we are able to hear you. So yeah.
There was some power failure, and I don't know why this is also stopped working. Pardon me for that. Okay. So we were trying to understand the ML, frankly speaking, where we are trying to, implement machine learning practically, and this is important from interview standpoint as well, right? So where were we? We were basically, I think, predictions within okay. Machine learning algorithms are used in a wide variety of applications. We've seen quite a few applications available. This slide is around, I think, 3 months old, so it talks about the older version. But newer versions, all specifically governmental agency or banking fraud networks or anti-fraud networks, even cybersecurity enthusiasts, they all use machine learning to detect any anomaly. So anything out of normal is detected and it escalated to a level where it can be triggered subsequent either checks and balances or action items and so on and so forth. So that's how we keep progressing on a step-by-step evolutionary manner. And we add all these events and learning to a library so that wherever we are in line or we are trying to build our response team, they are enabled with these machine learning tool sets as well. And again, this is evolutionary matter. This is not a one-time effort. You keep evaluating, you keep basically trying to tune up with the current scenario, current threats, current pitfalls, and try to build better and better solutions day by day. And that's why data scientists are in a need, because they help to build these solutions in a much systematic way, aligned way, so that the business gets the best possible solution from these machine learning paradigms. Okay, a subset of machine learning closely related to competition.
Sir, I don't think we can see the slides.
Oh,
Yeah.
pardon me. Oh, sorry, I forgot to share. I believe. Pardon me. Come on. How can I? The slides are open. Give me a minute. Let me try to open it again. Why can't I see this? Yeah. Could you see now?
Yeah.
Yes.
Yes, we can.
There are lots of things happening, not in a right way. But okay. A subset of a machine learning is closely related to computational statistics, which focus on making predictions and using computers. We talk about the exploratory analysis, right? So that we basically build our data, we study the historical data, and we try to extrapolate to a level where this data is being, channeled for the current scenario or the predictive model. Okay, so these are what we can normally call predictive models based on the historical data, because the history repeats, and that's what we also basically seen in our life. So what we do, we study the history, we study the situations, we study the progress, and then we extrapolate. This is kind of future predicting, but still we do this thing with quite a good accuracy, because as far as as we've done the tree, the decision tree analysis also helps us to basically zero down to the most probable event is going to happen, most probable temperature range, most probable what you can say, rain predictions or heat wave predictions or tornado predictions and so on. So we have learned these things from the data. We extrapolate those things and we try to present it to the business community or the user community. But not all machine learning is a statistical learning. Yes, we have other branches too. The study of mathematical optimizations deliver methods like building efficiency within business. So what we track about the defects are reported in a software development, the defects are reported in a new product creations, new products adaptability to the markets and so on and so forth. So here we normally trying to build a mathematical optimization models, theory and application domains to the field of machine learning. This also adds a really great help to the business to make sure whatever they are aligning in terms of business alignment, they can do much better than the normal model which we used to follow for ages together. The data mining is related to the field of study, focusing on exploratory data analyzed through unsupervised learning. Some implementation of machine learning use data and neural networks in a way that mimics the working of a biological brain. So there are certain scientific community which are really trying to understand how neural networks of a human brain functions and how we can get leveraged from that, try to implement those processes as in the biological brain to an actual brain and try to manage those learnings to be archived as a library. So that's what we call neural network, artificial neural networks. It is the application across the business problem, machine learning, and is also referred as a predictive analysis. So predominantly, predictive analysis is the easiest data solutioning. Then we can say overall the mathematical optimization models, which we can suggest the business, and then the NLP comes. Okay, neural linguistic programming. Even neural linguistic programming is a part of psychological learning as well. In psychology, what they are trying to do, they are trying to understand how human brain learns, how it reacts, and how it performs in a given situation. Similarly, we have that branch in our AI as well, artificial intelligence as well. Okay, so they are basically kind of supporting each other. But if you try to define these two, the definition will be a bit different, because here we are trying to make sure the machine learns based on our learning of a human brain. If you take a step further, in a psychological pardigram, those doctor or psychological consultant, they try to basically guide you on how your mind will perform in a certain scenario, or how the mind have reacted, or how criminal minds are working on a given scenario. So they can catch those they can catch those criminal much effectively, or they try to reduce the overall impact or damages happening to the society or to a given scene. And that's how this NLP is helping everybody across the board. Okay, there are, I think this question asked 2 or 3 times, how NLP in AI or how NLP in psychology does differ. So these are the difference. Those NLP in psychology are for human progressive thought process understanding. NLP in machine learning, we are trying to implement or we are trying to mimicking the human brain to understand or to make the machine learn on its own. Still, I'll say it's in a futuristic or science fiction kind of thought process, but still we have certain good what I can say alternatives. We are coming up with it. We are trying to implement the solution in a much better scope and sense, as in data scientist community. Okay, does that make sense to you?
Yeah.
Okay, great. And as we discussed last time, can anybody share their thought process on machine learning, what they understand as in machine learning? Anybody have thought on that? Defining machine learning. See, even as a data scientist, machine learning is a new paradigm. Yes, of course, you need to understand the definitions given, but as a person, as an an individual entity, I have my own thought process as in machine learning. So, can anyone want to put in their word? What do you think machine learning is?
Machine learning, I think it's basically a subset or a branch within artificial intelligence, by which, say, machines can basically learn by themselves instead of requiring a human being to program and make them work, right? So basically, a machine can kind of like, by its experience or whatever, right? Okay, can intelligently learn by itself and come with a solution rather than depending on a human being to kind of like code and make the machine work, right? So that's what I guess is a machine learning.
Great, great, great. It's really good stuff. Great, great. Anybody else? See, this thought.
I was gonna. Oh yeah.
Please go.
Yeah, I was gonna say maybe like something like Google Translate. Like, say if you could use Google Translate, then
Right.
like speech recognition. Say for example, so if someone says something into Google Translate, then if you want to translate something from English to Hindi or English to Spanish or something, then I guess the application, the machine learning inside the application knows what you're saying, and then it translates it into Spanish or Hindi or whatever language you want it to. Is it something
Right.
like that?
Yeah, even face recognition for that matter. So you're on the right track. Only as in data scientists, we need to understand how they do it. So you need to put in those things like, uh, how do we do the translation things? So what I've created a library of this means that and those kind of scenario. So when I say, well, when a New Yorker say, oh, shut up, this doesn't mean that you should shut up or stop talking. It means that, yeah, okay, I know what you're saying. So something like that. The machine learning is all about understanding these nitty-gritties of this translation, nitty-gritties of the cultural differences. Okay, and so on and so forth. In Hindi, the way we say might differ, but still we are evolving at that level. But still, right now, I think they have implemented the overall grammatical stances of Hindi to convert it into English. So the formal language conversion is at really the best possible conversions available for a given translation mechanism like Google Translate and all. Even in Japanese, we can translate in a great way. I think Japanese were the first to basically implement this in Japanese and Chinese, and they could do it to a great level because their culture is much different from English cultures, and British have never ruled their country, so they never had these cultural shocks like in India and South Asia for that matters. So for them, understanding English is pretty difficult. In India, we had English as an part of our growing up, part of our education system, and we have quite a few areas which really believe English is a mother tongue and all. So that's there. So we learn English from birth. But if you look at these countries, they never fiddle around this Englistic, phenomenon. So what they do, they build some really good translators, and they will be building this for 30, 40 odd years. So they have the biggest, what you can say, database of the local regional dialect converted to English. Or even for that matters, in China, there are couple of scripts like we have Devanagari, we have a couple of scripts in India. In China, they have hiragana, katakana. Same with Japan, Korea, and all. So what they've tried to do, they've tried to build these conversion techniques from one syllables to another, or one way of writing, one script to another script, and that's where they're really, what you can say, achieved a great number of success there. And then when ML comes the way in the last decade or so, we have tuned it to a best possible level. So if you go to Japan, they'll give you a translator, a small kind of a bit bigger pen. The pen what you write, the ink pen or the ball pen, you get a bit of heavy or bigger pen which can translate those things for you. You just it consists of a scanner, it consists of an LCD screen. So whenever you move that scanner over the newspaper, you can convert the Japanese hiragana, katakana to the English like text, and they'll give read it for you sentence by sentence, or para by para, and so on and so forth. So here what we are trying to do, we are trying to understand a dialect which is kind of foreign to us, to convert into a dialect which are basically that's our mother tongue, or we normally use that dialect extensively in our day-to-day life. So that's the way ML is also helping us out in day-to-day scenario. These examples you should be able to explain if interviewer asks. Okay, and that's why I'm basically stressing on this thing. That's why we are repeating these things. Sure. So let's move on. Now let's try to understand how ML is started and a bit of history. We have did this in last time, but I'm just repeating for to understand. Machine learning is a branch of AI, computer science, CS, which focuses use of data and algorithms to imitate the way the human learn, gradually improving its accuracy. Again, I'll repeat. Machine learning solution, data scientist solutions are not a ribbon cutting ceremony. They takes time. You might build the solution in months, but it takes time to get matured, or what I can say, to customize to the need for the given hour, need for the business, tuning. So there's a bigger amount of customization or tuning or alignment type of stuff needed in terms of machine learning solution than a normal software solutions. Why we are comparing? Because machine learning solution are a kind of software solution at the end of the day, but still they are much more than in just create the solution, deploy, test, UAT, and you're off to another solution. No, this solution is basically a kind of evolutionary in nature. So we try to understand, try to customize, try to align it to the solution, or we might modify the solution even after building the solution to make sure it performs exactly what needs to be understood, what needs to be given as a business results. IBM Arthur Samuel is credited for coining the term machine learning. So Arthur Samuel have patented this term machine learning, and that goes to his credit. With its research in 1962, he started using this term. He lost to the computer compared to what that can be done today. This feat almost seems trivial, but it's considered a major milestone within the field of AI. Over the next couple of decades, the technological development around the storage, processing power have enabled many innovations, products that we know and we love today, like Netflix, right? Netflix works on ML engine, which try to direct the sitcoms or the movies or the streaming media to a particular region based on their past history, based on their past likings. And the other is self-driving car. These two are exclusive to each other. In self-driving car, we of course learn from our history, but it's more towards what is there and how do we react to a given scenario. In Netflix, we normally rely on history and extrapolation of those history and try to predict the likings of humans. In self-driving cars, we are trying to understand the current scenario, the obstacles, the change in obstacles at a given point to a given point, and then we basically make the driving cars go ahead at a slower pace than humans, yes, definitely, but still they are improving day by day. Now there are commercial self-driving cars available in China. That was, I think, around 5 months back they have started. They are still struggling. They have started with around fleet of 20 cars. I think they have, increased to 25, 26 at the most. They couldn't go beyond that because there are a couple of, challenges, understanding obstacles and all those things. The most complex example is somebody throwing water on a windshield, and the car just got stuck there. And this water came from some, I think, nearby plant watering robot or something like that. So it was really, kind of, well, it was an exception, but still, they never, came across this scenario, or we have never made the car, what I can say, understand such scenario. Water being a kind of semi-transparent to a transparent level, so the even LiDAR detection on waters was sketchy. The cameras detected something as an anomaly, so they just stopped the car so that the impact shouldn't happen. But at the end of the day, the water that splashed on the windshield of a car, so it was an impact, so they just stopped there. So the machine basically that's the kind of normal response to the exception what we have programmed in that self-driving car. So again, we are still learning, we are still evolving, and self-driving car is into force from 2014, I guess. That Wyoming was the first car built by Google, which is still in progress. They have started, using throughout the Google campus. But yes, whenever they took it to the actual interstate, they tried a couple of times successfully, but the failures are much more than the success rates. So again, these exceptions we keep learning, we keep adjusting our solutions to. And yes, development is much easier in a typical ML or data scientist solutions, but the alignment, the tuning takes much longer time than the normal software solutions. Okay, you should be able to explain this thing to interviewer. Interviewers, you should be confident enough to share these things to the interviewer so that they'll understand you worked on ML or data science project. Okay, ML and data science project. There's no or to it. Okay, machine learning is an important component of growing field of data science. through the use of statistical method algorithms and are trained to make predictions, uncovering the key insight within the data mining projects. These insights subsequently drive decisions making within the applications and business, ideally impacting the key growth matrix. This is what the actual, I think, understanding of extending the decision tree we are talking about, right? So yes, whenever interview asks me, ask us basically tell me about the decision tree and their relevance in the machine learning or data scientist project, you should be able to explain it in your words. A big data continues to expand and grow, the market demand for data scientists will increase. Yeah, of course, it's increased a good level, requiring them to assist in identification of the most relevant business questions and subsequently the data to answer them, and so on and so forth. So this is how the overall data scientist demands is increasing in leaps and bounds. As we seen this thing last time, also I'm just repeating, AI is a superset, then we have machine learning, then we have deep learning. We haven't started understanding deep learning as of now, but still overall. But AI can be, quite a few others examples than machine learning as well. Machine learning can be a part or can't be a part of AI. Artificial learning, we talk about, there are sort of mechanical AIs also. What do you mean by mechanical AI? Like the car paint robot, right? The robot knows its procedures, robots know its events happening and the response to that, as simple as that. There's no new event happening or there's no exceptions happening for those robots. So for robots where there are no exceptions, we talk about mechanical AI, or normally referred as a mechanical AI, because we have event and response. We are just programmed that for event or response. If anything new happens, the AI just stops, the machines just stops, the robot just stops. Okay, so till you get a car bonnet, the car painting robot will not start. Once you get car bonnet, it'll have a scan throughout. It'll understand the curves, the ditch and the whatnot, or understand the overall shape of the the car chassis, and then start painting 360 degrees with all those spray paint gun and the combination thereof. And that's how the mechanical AI works. Okay. Yes, in data scientists, we normally refer it as a mechanical AI. So please do keep this screen. We had a look at machine learning models last time, and I have also shared some additional YouTube videos as well to understand how these ML models we are going to build or we are going to construct. These talks about various different libraries which we are going to use, and quite a few of them we are going to use as in our hands-on practice. So don't worry on that part. But this is how basically it's a kind of glimpse of what we are going to do in next few sessions. I also given you a lecture of an MIT. It's around an hour plus lecture. Scalable machine learning, Alex Friedman. This is really important lecture because he discusses on how the machine learning is being evolved or being targeted to evolve by the data scientific community. And these are kind of guidelines which we should understand how machine learning solutioning is progressing by leaps and bounds. Okay, what do you mean by deep? Deep machine learning can leverage labeled data set, also known as supervised learning, to inform its algorithm, but it doesn't necessarily require a labeled data set, and so on and so forth. So deep, the more you go deep in terms of layer, the more the more depth you achieve, the more deep learning you are implementing. Deep learning in the sense you are trying to go level by level deep into the overall supervised learning. Okay, and I believe we discussed this thing last time. Let's take a understanding of machine learning from a scientific community perspective. Machine learning is a science and art of a programming computers so that they can learn from data. It's a layman's language, a layman's definition. Is a slightly more general definition. Machine learning is the field of study that gives computers ability to learn without being explicitly programmed. This is by Arthur Simil, 1959. And more engineering-oriented one, a computer program said to learn from experience E with respect to some task T and some performance measure P of its performance on the T and as measured by P improves with the experience E. This is given by Tom Mitchell in 1997. This was one of the uh, best aligned definition for ML, what we normally use. Okay. Now here, as we say, experience E, task T, and performance measure P. These are the three parameters we're going to use in our program as well. And we're going to normally refer with these acronyms. So this is really great, definition. Any confusion in this definition, or are we on the same, page as far as machine learning thought process evolution goes? Anybody have any confusion? Have you
Yeah,
understood these engineering definitions?
yeah, good. So yeah.
The
Yeah,
last
yeah.
one is really important. I don't want you to mug up, but you should be, able to explain it by your heart, because I think we've done these things, right? We've learned it at a length. A computer program. So machine learning is a computer program set to learn from experience. So what we do, we build certain experiences to be implemented or accepted within the program with respect to some task. So there are some events, tasks, and we learn the experience in response to the task, and some performance measure. So the response or the performance to be correlated to that task T. And these three combinations, if it's performance on T and measured by P. So all these three major entities came together in our programming to make sure we learn from our experiences. The machine learns from its experiences. Well, automatically, if not, that's another way to address it. But right now, it's more of supervised. Unsupervised is there are no teacher as such. But yes, we need to have some teacher. We need to have some supervision as of now. And let's be realistic rather than sci-fi movie kind of scenario. Okay. Still, we haven't achieved a complete unsupervised learning in terms of machine learning. There are tries, there are failures, there are some shortcomings on that part, but we are still learning. There are some commercial robots available which basically claims that they've started learning unsupervisedly, but still at the back of the solution, there are some manual efforts required on almost daily or weekly basis to make sure whatever they have learned in terms of event and response type of pairs need to be archived to the library so that even others can learn, and so on and so forth. So we'll discuss about that whenever we actually do the programming. Okay, so don't worry on that part. So I take it you don't have any confusion in this engineering definition, which is the most crucial definition, and you should be able to explain the definition in your own word. Okay, it's given by Tom Mitchell. Okay, let's move further. Let me now we are going to basically shift to case studies of these ML, right? So let's start with the first and the simplest one is basically the spam filter we are talking about. Where am I? Could you able to see my screen?
Yeah, yes.
Okay, case study spam filter. This is the most easiest example you can explain it to the interviewer. In case if you're not don't want to go to a level where you might it a couple of minutes to example to basically substantiate example. But here this is the simplest one. Have you all used spam filters in your Google, Hotmail, or whatever email accounts you used?
Yes.
Yeah. Can you tell me what you mean by spam filters? What they do for you?
Once we categorize a certain email as spam, and anything related to that kind of email will be automatically put in the spam filter from next time onwards.
Right. Could you explain me the process how the spam email has been marked as in spam?
Probably it'll look for certain keywords, and then maybe it'll flag like if it's coming from this number or this email and with this content.
Recipient or this sender. That's right. Go ahead, please.
With this kind of maybe it has label of some advertisement saying which you don't want. So from next time onwards, that kind of mails it puts in the spam filter.
Right. ma'am, just a suggestion. Whatever you speak, speak confidently. I know sometimes we might not be right to the dot, but unless and until you speak confidently, nobody will believe that you're speaking, from your experience. And we need to basically present it that way. Could you understand what I'm trying to say? Don't feel bad about, what I'm suggesting to you. I'm just giving you a suggestion, right? Yeah. So speak confidently. You are right. You are not using the correct words, but you are right to the point. As in, you could explain what is spam. Okay, there are many other aspects to it. Oh, what the heck happened? Okay, so you're right. Anybody else want to explain? And yeah, we are all learning, so don't feel bad if I say something to you. Ma'am, please, no disrespect to you.
No, that's fine.
Please, thank you. Anybody else want to, share their thought process in terms of how we basically make the classification, like this is spam email or spam chat or whatnot? Anybody? This is a need of understanding, because unless you understand, yeah, please go ahead, sir.
Usually sometimes, like in a spam email, you can see in the text that there's some misspelled words, or there might be some misspelled subtext in there. And then if you read the email heading, then you can see where the email might be coming from. Then you can maybe source it out to see if it's a valid email address or not. And then but nowadays, like with email algorithms and stuff, usually spam mail just goes straight to a spam folder. But technically, how I would identify spam is I would look for the text and where the email is coming from and how the text is layered out and stuff like that.
Great. Now, what you are added to the thought process which madam have just started. So you said spam is from a spelling mistakes. Spam is basically from the already marked bad source. If I can, use these words for madam's explanation. Okay. So these two, there are some more to it. More way, how do you mark the spam? Anybody else? Balaji?
Probably if you hover over the hyperlinks, right? Okay, then you may the hyperlinks may kind of like seem genuine, but when you hover over it, right, then you may kind of like that's when you can see that the URL may not point to a proper source. It may be coming from a probably, say for example, let's say like google.com, right? Okay, the hyperlink text may read like a google.com, but if you hover over it, right, it'll point to a totally different website. Okay, so that's one way we can identify as spam.
So you are talking about the phishing attacks.
Yeah, correct.
The phishing emails, right? That's right. That's another. Okay. Now all these learnings club together and some more, and we'll discuss that thing and in a couple of slides. But still, what we're trying to do, we are trying to basically categorize our incoming message, which are not needed by me. In short, right? Which are not relevant to me, or which are disturbing in nature to me, which might be damaging in nature to me, right? And these are all what spam is all about. Spam is the thing which is not needed in simplest form, and we keep building this thing, we keep evaluating these things one way or the other. There might be a scenario by mistake I classify it as a spam, but then I realize no, that was really message from somebody which I know, and these things do happen. So normally, as we've discussed, there are certain words like cells, there are certain words like offer. These are normally get flagged as a spam right away if it's not from a known source. And this is how we started building these spam filters. Okay, let's try to understand how we can do it programmatically. For example, spam filter machine language program that can learn to flag spam. Give an example for spam emails flagged by users. So if I flag, it keep a track of why I flagged that email, or the filter can ask me, why do you want to flag this email as in spam email? So I'll give some example which the ML program can remember, and then it can apply it the next time any emails come to me. The example of regular non-spam is also called ham emails. The examples that system uses to learn are called training set. So these are the training set building. We are building some training set for to apply to the given incoming emails, and that's what we call filters. Each training example is called a training instant or a sample or a filter. Now this we keep building. Again, this solution is not a perfect to start with, but we will get it perfect to a level where my emails in my email box might be limited to 7 or 8 emails, or depending upon your work and all those things, they are limited in numbers than 100 and thousands of emails. And the older your email box is, the more spam you get. I have a mailbox which I have created in 1995 called ravi22@hotmail.com. I still use sometimes. And the normal email intake is around 3,000 email per day. And out of 3,000, almost 21980. So I hardly get 10 or 20 email which are relevant to me. And that's how it works. So the older your email box, the more disturbing it's, or the more spam filter you need. And that's how spam filters are important. In this case, the task T is to, now we are trying to implement our theory, right? The T, P, and E, what we have said, right? So the task T is to flag a spam for a new emails. And the experience E is training the data, and the performance measures P needs to be defined, or we keep defining them as and when we go. And it's an evolutionary practice. For example, you can use the ratio to correctly classify emails. Now, the ratio here, what he's talking about, how many spam I have, flagged yesterday or in the last month and this month and so on. So I'm trying to understand how progressively I'm improving. Am I improving or not as well? So this refers to the efficiency of the solution as well. This particular performance measure is called accuracy, right? Or the proficiency, right? And is often used in the classification of a task. So this does guide me. So am I doing it right, or am I going worse, or from bad to worse, or bad to better? And this is what the kind of integral part of the machine learning. Okay, now what I'll do, I'll show you two flowcharts. These are normally flowchart. You might call them activity diagrams or whatnot. But let's try to understand how the traditional approach differs from a machine learning approach. Okay, who wants to explain me these things? These are simple things, but I want to understand from your words. Who can explain me these things? Anybody? No one? That's strange. Yes, ma'am. Please go ahead.
Okay, I'll just try.
See, it's a try, and don't feel bad if we discuss in case of some shortcomings. This is how we are learning, right? Because at the end of the day, we need to face the interviewer, right? So for that interview, this is what we are all trying to achieve. Okay, please go ahead, ma'am.
Okay, in the traditional approach, first get the problem. What's the problem?
Mm-hmm.
You write some rules, and then you evaluate or test it and see if you still have any errors. Then go back and revise your problem, and then write new rules, and keep doing that until you think there are, in your evaluation, you don't find any more errors. Then you can launch that code or whatever the program you have. That is the traditional approach.
Perfect.
In machine language, you study the problem, and then you train the machine language algorithm with your training data.
Mm-hmm.
And then you evaluate the solution and keep analyzing for errors, and revise your machine language algorithms with the data. So the training of the algorithm with the data is what is different in machine language compared to the traditional approach. Then until you see you don't have any errors, and then you can launch the program.
Could you explain this thing with a bit of technical terms, ma'am? Just give it a try.
Technical meaning
In the sense, what do you mean by trained ML algorithm? How do you achieve? What type of business rules or filter you will program or will try to create?
Okay, so train the ML algorithm, basically you're making the machine learn. So in order for the machine to learn, you have to input some pre-cases like pre-existing or the cases that you think are suitable. And that's the way you train the data. Like you give some use cases, some examples, like for example, like if it's rainy, you don't go out and play. And you keep looking for data, and then probably there will be a sunny day, and then you can say it rains. But while you're training the data, probably there's another condition which comes which says there's like windy. So do you want to play or no? Then the data wouldn't the machine wouldn't know that. So that in that case, again, you'll face errors. Then you can come back and revise your problem saying that if it's windy and if it's also sunny, then maybe I'll play. But if it's not too windy, I won't play. So that's the way you're training your data with revising the conditions so that data can be categorized in a more efficient way.
Sure.
And is that what you're thinking, or is there something else that I need to say?
Sure. What I'll suggest means all of us basically try to think on this, try to spend some few minutes on this, and try to, because I believe we've discussed what are the things we need in the spam filter. So try to basically describe in your own words what type of data, what type of training algorithms you are trying to build in these spam filters. Okay, what type of like we talked about the repetitive words, misspelled word, unknown source, and those kind of scenarios. So try to build some rules, and that's what the algorithm is all about, right? So you should be able to specify a rule for a given scenario rather than you were discussing about ML program we tried to do, right? For that, should I play out or not, those kind of scenario. I can understand that, or you can build a case study on basis of that. I think we have solved that example when we were doing decision tree. Now decision tree was a thought process, and we've learned that. Now we are talking more about implementing that thing. Okay, so the homework is try to build some rules, try to build some algorithms, and that's how we say algorithms. And these are the technical terms need to come into our thought process or discussions whenever we try to discuss this thing. Okay, so please build, spend some few minutes and try to build some how to build the training algorithm for this machine learning approach. Okay, and then we'll might discuss it in our next session. Again, there's no right or wrong here. We as a personal artist, we try to, or personal scientist, as an individual scientist, we try to build a solution, and you should be able to explain it. There should be at least 1 or 2 samples which you have to explain it to the interviewer, and you can include this as in your project as well. And this is a need of the hour. I believe somebody have asked me what project I should include in my profile. You can include this project, and then you can discuss it at the length about practical approaches. How do you basically train your algorithms? How you build those rules? What type of data do I have filtered, and so on and so forth. So for that also, this is a good example and the simplest possible example. Okay, so do spend some time on that, and we might discuss in our next sessions. Okay, any question for me on this? Ma'am, you did really well. Don't I think you explained that decision tree wala example really well, but we should be able to explain one of these examples as far as interviewers interviewing process goes. Okay, does that make sense, or am I troubling you too much?
I understand it.
Yeah, very good.
Okay, so spend few minutes and we'll discuss this thing. This is a need of the hour. Unless you prove yourself, the interviewer won't be confident that you could do something, right? So for that, this is the simplest example we can explain to him. There are many more. Don't worry on that part. I'll give you sufficient number of examples to choose from, but let's try with the simplest one. And within our session, if you can explain it with your thought process, then I'm quite confident that we are not just faking anything, frankly speaking, and you can speak with the full confidence. That's what I want to make sure, and that's why I'm traveling in this way. Okay, let's take a step further. And please stop me if I'm going too technical or if I'm trying to unnecessarily pressurize you for something which you don't want to do. Okay, please do speak out clearly. Now, let's take a step further. How we can do it automatically, right? I'll not say this is a science fiction, but again, what we are trying to do, we are trying to achieve something to be done by machine itself rather than me supervising every time as a data scientist or as an programmer, manager, or whatnot. Okay, let's try to understand this flow chart or activity diagram, whatever you want to call it. If spammers notice that all their emails are containing for you are blocked, there are, as I think the have explained, for you is basically a misspelled or a kind of, a quite informal term which you use. And normally, friends, when you do, when you use WhatsApp or something like that, you use this terminology. So these are like non-formal emails or non-formal messages come to you. And that's what we told this, what you can say, the training rule for these, machine learning program. So that's why a spam filter using traditional programming techniques would need to be updated to the flag for you emails. So if there's email with a subject line for you or containing something like for you, to be marked as a spam. I'm just taking a raw example, right? And sometimes it might be in your business, like you have a colleague who sends or type emails like this, so you couldn't apply this filter generally, or you need to apply an exception. So for Ravindra, for you is his normal way of communication, so please don't mark him spam. Okay, it was a joke, but yes, this is how we need to build our business rules, right? So if spammers keep working around your spam filter, you'll need to keep writing new rules forever, right? So it's a continuous implementation type, implementing type of process. It's not a solution. I have take product and start using it. No, the product has to be customized, aligned with your need, and that's the evolution. That's the kind of fine tuning or business alignment we need for data scientist solutions, for machine learning solutions. In contrast, a spam filter based on machine learning techniques automatically notices that for you has become usually frequent in spam filter, a spam flag by users, and it starts flagging them without your intervention. Now, after a certain time, the ML have understand what type of phrases, what type of words are informal, or it can basically get itself updated from a data feed of informal phrases, and then it start basically marking the mail with informal subject lines as in spam. And yes, this is how the Google works, frankly speaking. Google have a data of informal phrase. So whenever you're using your email for a formal purpose, like I do, there, if you tell Google all informal phrases go to spam, yes, so it will mark every informal email to a spam, and it does a lots of help to you in terms of you get hardly few emails to watch. But yes, then you have additional work to actually skip through in the sense, go just roll your eyes over the spam filter also, because sometimes as a machine it may do some dumb things. But I shouldn't say this as a data scientist, but yes, we are in an evolutionary mode, and that's how it happens. Okay, how far we'll be in evolutionary mode, I don't know. Sometimes I might find I'll skip that skipping through my spam folder, but if I get a time, at least once or twice a week, I go through my spam filter before it flushed out those mails. And yes, we should also, it's a kind of, you can say, a review of the output of a spam filter, which I have already implemented in my Google Mail. There are around 1200 plus spam filtered techniques implemented or products implemented for a given box. For Google, there are around 850 plus spam filter add-ons available in Google Chrome. Search it out. So they have all these rules made up, and you can also substantiate your example description with the interviewer whenever you try to discuss this spam filter kind of the ML program. Okay, so do work on it, and I think data is available. That's why I normally keep these things whenever you try to showcase any example or showcase any project, so that you you basically guide in this is what I'm doing and so on so forth. Okay, so please have a look at these things and you'll get a really good idea of how ML project or the simplest ML project can be understood, can be explained, can be basically understood in its nitty-gritty of the processes and the rule implementation type of way as well. Does that make sense to you?
Yeah.
Yeah. Any question as of now for me?
No.
Okay, let's take a step ahead. Now we talk about the NLP, neural networks. Sorry, we talk about neural networks and then we'll talk about the NLP, neural linguistic programming. Neural networks or AI neural networks. Now, yes, in data science particularly we call them ANNs as well, are comprised of a node layers containing an input layer, one or more hidden layers, and an output layer. So we do something like, you have an input, you process something on the process thing, and then you give an output. So something like that. So each node or an artificial neuron connects to another and has an associated weight and threshold. Now we are going into the technicality of it. If you have a look at a YouTube of video of how neuron functions, I'll not share with you. Have a look at by yourself how brain neuron functions. In our brain, we have something called neurons, a kind of nucleus, and a wrapper around it of nerves, which connects to the another neurons. Now these neurons speaks to each other with the electrical signals, electrical impulse. They're really low at electrical signals or impulses for different sensations. So when I eat anything, if I like it, the tongue will the electrical impulse to these neurons, and neurons will basically store it somewhere in our storage brain or something like that. So whenever I want to understand what I have eaten yesterday or morning's morning's lunch and whatever I like, so my brain will come back to me with the memory, and it will basically explain me, you have eaten something like balu shahi, aloo poha, whatever you like. I'm just basically trying to share the working of a neurons with you. Similar way, each of such node or artificial neuron, that's why we call them artificial neuron. These are like a center of those electrical impulse network, connects to another with these neural network with this electrical impulse traveling muscles, and has associated weight and threshold. So there's a weight and threshold. If the output of any individual node is above the specified threshold value, that the node is activated, sending the data to the next layer of network. So we are passing the data from one node to another, one artificial neuron to another within the network of these neurons. Otherwise, no data is passed along to the next layer of the network. The deep learning is just referring to the depths of layers of the neural network, as we just discussed, right? So deep learning is basically how many layers of such neurons or such messaging transferred layers are there in your solution. Basically categorize the deepness of the deep learningness of the solution. A neural network that contains more than 3 layers, which would be inclusive of the input and output, can be considered a deep learning algorithm or deep neural network. So once you have at least 2 layers of such neural networks, you can specify the solution as a deep learning solution. A neural network that has only 2 or 3 layers is just the basic neural networks. I'll share some IBM based link to you where you can learn about these deep neural networks, or what is the deep learning is actually in terms of data scientific solution groups we talk about, right? So this is just, we are trying to understand, if somebody asks what you mean by deep, or what you mean by neural networks, how neural network function, this is the answer for that. Okay, I'll share the PPT again today so that you can review these terminologies and you could basically revise on whatever we did today. I'll try to share the recording as well. The next, how machine learning works. Now there are three independent entities here we are talking about: a decision process, an error function, and model optimization process. Okay, let's try to understand one by one. Here, in general, machine learning algorithms are used to make predictions or classification. Like we use the decision tree and we try to extrapolate based on the data and historical fact. Based on some input data, which can be labeled or unlabeled, your algorithm will produce an estimate about a pattern in the data and try to extrapolate it. Does that make sense? Could you understand what I'm trying to say here? Or how does decision process can be extrapolated to present a data in future or in near future, as data scientists normally say? Okay, could you understand what is a decision process? Any confusion here? Could you hear me out, or am I not audible? Am I audible, sir, madam? Hello?
Yeah, you're audible. Yeah.
Okay.
No, yeah, we could get it. Yeah, no worries. Yeah.
Okay, no problem. Because these three are important terminology and we should understand it. And that's why I'm trying to explain it. So a decision process, in general, machine learning algorithms are used to make predictions or classification based on some input data, which can be labeled or unlabeled. Your algorithm will produce an estimate about a pattern in data. Okay, so we are basically trying to build a trend analysis kind of scenario to the nth level. An error function. An error function serves to evaluate the prediction of a model. So what we are trying to do, we are trying to predict the model or predict the repetitions. And if there are known examples, an error function can make a comparison to assess the accuracy of a model. So we are going a step further than a decision process. We are trying to validate the prediction which we have made. We are trying to basically make sure whatever prediction we made, it's true from our previous learnings, or basically check the validity of it on a given type of checks and balances which we can include in this solution. And model optimization process, and the next step is basically we try to optimize this model so that the solution will be much more efficient. If model can fit better to the data points in the training set, then weights are adjusted to reduce the discrepancy between the known example and the model estimate. Now here, once we start understanding what is right and what is wrong, we try to choose more gain, more accuracy, more rights and less wrongs. Or less, we try to reduce the noise, or we try to reduce the entropy and try to achieve more and more gain. The weight algorithms will repeat, disevaluate, and optimize the process, updating the weights autonomously until a threshold accuracy has been made. Now, this is our dream. This is our basically the last result we want to achieve. I want to have a robot which can function independently, which can get me a tea at 6:30 in the morning, which can basically massage my feet in the evening, which know how to do what at what time, and so on and so forth. So that's the kind of dream what I'm working on, and this is what the statement says. The algorithm will repeat its will repeat this evaluate and optimize process, updating the weights autonomously until a threshold of accuracy has been made. So this is what I want to achieve, and I'm still trying to achieve that thing in the real practical scenario as well. Have I started? Yes, I have definitely started on that, but still I believe there's a bit of way to walk through to achieve these things. Does that make any sense to you? Anything which I have confused you with, or you couldn't understand?
Yeah, I understand.
You're good, right? Have a look at this thing. I'll share the PPT as well. Have a look at these things again couple of times, and you'll understand how we are basically going into understanding the machine learning in a step-by-step way. Okay, let's try to understand types of machine learning. There are three distinct types: supervised learning, unsupervised learning, and reinforcement learning. As the picture clearly depicts, supervised learning is basically I'm working with an infant, a KG2, class 1, class 2, standard 1, standard 2 students, where I'm closely monitoring over the shoulder and try to make whatever he is learning to the best of my knowledge, and he keeps learning in a specified disciplined way. Then the next step is basically the kids age from 7 year plus till 14 years, where I basically not look look on his shoulder each and every time, but at least twice or thrice a day to make sure whatever he or she is doing is basically learning on its own. And that's how what we call unsupervised learning. And there's something called reinforcement learning, where he's an adult, he can learn on his own, he can get things sorted on his own. And this is as simple as, or as in layman's term, we can explain these three types of machine learning. Again, now we need to implement this thing in a programmatical or solution sense. Okay, are we clear on these three things in a layman's terms? I have specifically opted out the technicalities for the first version because we need to explain these to the interviewer, and in quite a few interviews they typically ask you the types of machine learning and what do you mean by supervised and unsupervised learning. Reinforcement learning, well, we're still struggling to achieve that thing in the practical scenarios, but at least we've achieved supervised and unsupervised learning up to a great depth. So have you understood these three types in the layman terms?
Yeah.
Yeah, we are good. Yeah.
Okay, great. Now this is really crucial to understand these terminology, because unless you understand the difference between them, it's difficult. Now let's take a step further, and oh man, this is really blurry again. But let's see. I'll read it for you, don't worry. Definition: supervised learning is a method in which we teach the machine using labeled data. So here we used a kind of in a layman terms, a teacher or a trained labeled data to guide machine in terms of what to be done, what not to be done. In unsupervised learning, the machine trained on unlabeled data without any guidance. So in labeled data, I have a specific events label. So if there's an obstacle, you should stop, slow down, something like that in self-driving car. In case of unsupervised learning, I have already fed in all the data I had in terms of obstacles and in terms of response to those obstacles. A cow walking on the road, well, this does not happen in North America, but in India, yes. A cow walking on a road. So how should the driverless car should respond? Well, the event have been planned, the response have been actually planned and included in the database. But as we just discussed, a water splashed on my windscreen, which was not a pre-programmed or pre-known or labeled data in my car. So what car did? Car just used the topmost exception level and stopped itself on the road or whatnot, right? So this is how the supervised and unsupervised learning works. In supervised learning, the car might have a data to refer to in case of what category or what type of labeled data is occurred now and how the response should be, or should I switch to manual mode or so on and so forth. In unsupervised learning, there is no something called manual node. All the nodes and possibilities have already been programmed. In case of reinforcement learning, an agent interacts with its environment by producing action and discovers errors or rewards. So here we are going quite a few steps ahead in terms of building the environment with an agent by producing actions and discovers errors or rewards. So here I'm trying to discover new errors or new rewards to make sure how should I function. Now this again basically evolved from the psychology, where I don't remember the scientist's name, like to a kid, if we are given a candy every time he does a good thing, right? And that kid will basically keep doing all good things in basically in the thought process of wanting that candy every time he did some good thing. And that's how the overall learning progress with the errors or rewards and with the discovery thing. And that's how we are still working on these robots. There are some, clearly auditory progress, like we have humanoids, like the Sophia and other. We have certain sort of automated robots, like mechanical robots in various other industries. And so we are basically making our way on reinforcement learning as well. But most of it, it's really a science fiction to even scientists as of now. And we are trying to make the autonomous learning in work in a real life. Okay, so that's where the gray area is. Does that make sense to you? Have you understand the technicality of supervised, unsupervised, and reinforcement learning? Or am I contradicting with your previous learnings? These things do happen because many students or many participants have their conceptions built on certain scenarios, right? So they keep discussing those things also. If you have anything, please do discuss. I like to get corrected, believe me, and that's how I also learn. So I believe you understood, right? What I've just said.
Yeah, I basically the thing is like we essentially are hearing it for the first time, right? So there is some inconvenience,
Yeah.
but if we go through once, right, maybe once or twice, then I think we will get a lot better idea. Yeah.
Sure. Now we are basically getting into the data scientist shoes. So it's itchy, it's difficult, and yes, you need to practice on it. No problem. So I'll share the PPT and everything. Don't worry on that part. Let's take a step further. Now, ML methods for supervised learning. Should I go ahead or should I stop here? I'll ask that question because here we go depth into the ML, how we basically implement these models and how we basically try to understand the theory behind it, and then we'll go on basically implement these things programmatically, and that's how I normally progress it out. Should I stop here to do your revision and then go ahead in the next session? Do you like that? Or should I continue? Okay, I'll continue. No problem.
No.
Please speak, sir. Don't worry. I'll not bite.
No worries. Yeah, you can continue. No issues. Yeah.
Okay, no problem. Because I know today we never had a video also. So even I'm just speaking, and you're just listening. Well, you spoke a couple of times. That's okay. Okay, so let me know if you get bored with this technicality. And yes, it's a heavy topic. It's a difficult topic to understand. We are trying to venture into a world where it's a bit of geeky world. Believe me, I can understand that clearly. Okay, so let's try to understand the ML methods in supervised learning. Supervised machine learning is defined by its use of labeled data set to train algorithms that to classify data or predict outcomes accurately. Now, this is a definition. I know I'm laughing, and yeah, first time I read this definition, I also thought, what the heck these guys is trying to mention here. Supervised machine learning. Well, of course, yes, supervised machine learning defined by its use of labeled data set. Okay, so we have some data which is labeled or categorized to train algorithms. So we made some rules as well, some filters like in spans that to classify data. Again, why are classifying data? Because that's we do in a pre-solution party terms, or to predict outcomes. Well, yeah, that's I can understand. But why to classify data again? Now let's try to understand this definition. The classification of data basically talks about alignment of data rather than or categorization of data to the nth level, so that the machine don't have to spend time effectively looking for the aligned data or effectively looking for which actions to take in a given exceptional scenario. And that's what this overall labeled data set with the predicted outcomes or already classified or reclassifying the data as per the required by solution does happen. And that's why this supervised machine learning definition puts it so. because it's an integral part of the solutioning. Or we need to keep realigning these data by leaps and bounds or within our solution. So that's why the solution is not, I'll not say complete or have not achieved its business objective till we get the data aligned, till we get the data categorization or classification complete up to a great extent. As input data is fed into the model, it adjusts its weights until the model has been fitted appropriately, and this is what the data alignment is all about. This occurs as a part of a cross-validation process to ensure the model avoids overfitting or underfitting. Of course, we are trying to exclude entropy and include as much gain as possible. So overfitting and underfitting will be excluded. The noise will be excluded, and so on and so forth. Supervised learning helps organization to solve a variety of real-world problems at a scale, such as classifying spam filters, we just see, in a separate folder from your inbox. That's what we do, right? Some methods using supervised learning includes neuron networks, naive bias, linear regression, logistic regression, random forest, support vector machine, and so on and so forth. We'll have a look at these differences. We'll practice a couple of them as well. Okay, so this is what the supervised learning is all about at a practical level. Let's take a step further and try to understand how we implement this supervised learning. Supervised learning, consider yourself as a student sitting in a maths class, wherein your teacher is supervising you on how you're solving a problem or whether you are doing it correctly or not. The situation is similar to what a supervised learning algorithm follows, like we just discussed, right? With the input provided as a label data set, a model can learn from it. A label data set means for each data set given, an answer or a solution to it is given as well. So it's mentioned there. And this would help the model in learning and hence providing the result of problem easily. So we have a label data set, we have a trained model to achieve to, and then we revalidate the model or we reclassify this data as and when we go on evaluating that thing. And that's how the supervised learning is being evaluated on a day by day. I have a really good read for you. I'll share that link with you. And so it's more of a reading than a video watching as of today. Okay, now this is a normal understanding or normal what you can say flow chart of building a supervised learning solution. So we have input raw data, which is inputted or fitted or filtered by an algorithm with a trained data set, with a trained model or a desired output already thought through with a supervisor in charge. So the algorithm applied to the raw data, filtered through a desired output with a trained data set aligned by a supervisor, and then we do a processing on a bit, and then we categorize or reclassify the data as per the need by the business solution. In the simple scenario like spam filters, we have all emails as an input raw data. We have some rules, algorithms made, so that if you have anything like informal words, phrases, anything like known spam email sender, or known challenging attachments from a sender, we categorize these things, or we have a trained data set to filter these things as a spam. I also revalidate the output so that it won't basically carry on any damaged goods, and this is also done by with the help of. So if anything exceptional happens, supervisor there is there to guide us all in case of the processing of these spam filters. Now the output can be inbox, the other categorized email folder, and a spam folder. And that kind of output we are expected in terms of supervised learning. Okay, now it's almost 10:30. It's almost 10:30. So I'll stop here. And in the next session, we'll revise supervised learning, and then we'll move on to the unsupervised learning to understand how unsupervised learning is basically going to help us out in building the solution, or what type of solution building techniques differ from the supervised learning, and so on. So, okay. Any question for me at this moment?
No, we are good, sir. Yeah.
Yeah, I'm
Okay,
good.
I'll share this PPT as well as the recording in a few hours, and you can have a look at it. So the next time we can basically go deep dive into the unsupervised learning. Once we understand the three differences, then we can start building the programs on first on supervised learning, then we'll go on unsupervised learning, and we'll have some really good hands-on workshop so that you can explain those solutions within your interview as well. Okay, sure. So let's stop here today. Thanks a lot for your time. You have a good night. Bye bye.
Sure.
Take
Thank you.
care.
Thank you. Bye.
Thanks. Yeah.